Hello. Now let us talk about maximum in plane shear stress in plane stress transformation. So let us begin with this. Now we know if we have a body and these are the normal stresses sigma x and sigma y, and we have a shear stress of tau xy, and then we want to find the stress on this oblique plane which is inclined by some angle theta. Now we know there is going to be a normal stress on this plane sigma x prime, and there is going to be shear stress on this plane tau x prime y prime, and this plane is inclined at an angle of theta. Okay, now we know normal stress on this plane is sigma x prime is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine of 2 theta plus tau xy sine of 2 theta, and the shear stress on this inclined red plane is tau x prime y prime is equal to negative, here it was positive but in the shear stress it is negative, sigma x minus sigma y divided by 2, here it is cosine but in the shear stress we have sine of 2 theta plus tau xy, here it is sine but in shear stress we have cosine of 2 theta. Okay, so these are the stresses on this oblique plane, red plane, right? Now we have to see any plane which is at an angle of theta, and we have to see at which angle there is this tau x prime y prime is going to be maximum or minimum. Okay, because if you see this, you can see this tau x prime y prime is function of sigma x sigma y tau xy, that is these stresses, right, and also the theta, right, as you can see here. So the shear stress on this oblique red plane is a function of all of these, but if we keep it constant, so it means shear stress tau x prime y prime is function of theta only, right? So theta is what? Theta is the inclination of this oblique or transformed plane, right? Now it means if we plot this on an axis, let us say this is theta and this is tau x prime y prime. Okay, so it means as we change the theta, so tau x prime y prime changes. Okay, so let us say, for example, let us say the the change is like this. Okay, it means shear stress is minimum at this place and the shear stress is maximum at this place. Okay, and this place is in between the maximum and minimum. Okay, so this is tau max. Okay, this is tau min. Okay, now keep in mind that this curve is not standard curve, it is only to me explain to you. Okay, maybe there is no tau minimum in the shear stress. Okay, there is no minimum shear stress. Okay, or they may be equal. Okay, so we will see that when we see the exact formula. Okay, so now from mathematics we know for tau x prime y prime to be maximum, right? So I will write here for tau x prime y prime, which is a function of theta, and for this to be maximum or minimum, okay, we should have this differentiation of tau x prime y prime with respect to theta, it has to be 0. Now we know this from mathematics or calculus classes, right? So if we differentiate this term with theta and equate it to 0, we will get that angle. Okay, because you can see here this is an angle, this is a particular angle at which this tau max is, at which this tau max exists. Okay, so we will get this angle, okay, maximum, or if there is a minimum. Okay, so we will get that angle. Okay, so now we know tau x prime y prime is equal to minus sigma x minus sigma y by 2 sine of 2 theta plus tau xy cosine of 2 theta, right? So let us differentiate it and equate it to 0, right? So it is going to be d by d theta of all of this and equate it to 0, right? So now this negative sigma x minus sigma y by 2 is constant, right? So it will stay outside, minus sigma x minus sigma y divided by 2, and we are going to have differentiation of sine of 2 theta, right? Plus again this tau xy will stay outside, and we are going to have differentiation of cosine of 2 theta with respect to theta, okay? And all of it is equal to 0, right? Now we know differentiation of sine 2 theta and differentiation of cos 2 theta, from the basic calculus classes. Differentiation of sine 2 theta is what? 2 times of cosine of 2 theta, right? 2 times of cosine of 2 theta, and differentiation of cosine of 2 theta is negative 2 sine of 2 theta, right? So when we substitute these values, it is going to be negative sigma x minus sigma y divided by 2 times 2 times cosine of 2 theta plus tau xy. Now this is negative, so I will keep it outside, times 2 times of sine 2 theta is equal to 0, right? Now this 2 and 2 will cancel out, okay? Now if we rearrange this equation, if we send one term to the right hand side, okay, so we are going to have negative sigma x minus sigma y divided by 2 times cosine of 2 theta, it is equal to tau xy sine of 2 theta, right? So let us throw this cosine of 2 theta to this right side and this tau xy to the left side. So what we are going to get? We are going to get negative sigma x minus sigma y, right, whole divided by 2, right, divided by tau xy, right, it is equal to sine of 2 theta divided by cosine of 2 theta, okay? So we know sine of an angle and cosine of the same angle, it is tangent of that angle, so it is tangent of 2 theta, right? So from here we got this relation, tan 2 theta is equal to negative sigma x minus sigma y divided by 2 divided by tau xy, okay? So this thing is what? It is the angle at which we are going to have a minimum or maximum shear stress, okay? So we will denote this angle with theta s, okay? Theta shear, at which the shear stress is maximum or minimum, okay? So now let us plot this, okay? Let us plot this. Now let me draw two axes. Now tan theta, okay, we will draw, you can see it, this thing is always negative, okay, because in the numerator we have a negative, okay, and in the denominator we have a positive. So negative divided by positive is what? Is always negative, okay? So also that if we multiply both sides with -1, okay, -1 and -1, it is going to be negative tau xy, and negative is positive, okay? So again it is going to be again what? It is going to be again negative, because in the denominator is negative now, okay? So whatever the case is, this the geometry of this is always negative, okay? Because we know when we have a function of tangent, okay, the graph, the tan function have always, it gives us always two angles, okay? So it means we need two triangles, okay? Two right angle triangles, okay? So if you see the property, it is a property, okay? So if you put this in the calculator, okay, and you put the real values, you will always get two values of theta, okay. So it means this tangent function is, it is a dual function, okay. We have two, values of theta, okay. So we have to draw two triangles, okay, but here it is always negative, right? So from basic mathematics, if this is coordinate system, okay, so we know this side it is negative, this is positive, this is negative, and this is positive, okay. So if we draw this tangent of 2 theta, it is always going to be in this quadrant because it is negative, and also in this quadrant because it is negative, okay. So let us draw them here, okay. So if we draw a triangle, okay, but we need two triangles because we are going to have two values of theta s. So we will extend it this side, okay. So these are our two symmetrical triangles. If this is 2 theta s, this is also 2 theta s, right? Now we know tan theta is what? Tangent of an angle is perpendicular divided by base, right? So this is the perpendicular and this is the base, okay. So let us see, this is sigma x minus sigma y by 2, okay, because this is the perpendicular, right? So this is the perpendicular, but this is the, what side is this? You can see if this is, for example, sigma and this is shear stress. Now you can see this is the positive side, okay, positive, sigma x minus sigma y by 2, okay, but we can also draw the negative, right? So this one is sigma x minus sigma y by 2, okay. Now this one is negative. Why it is negative? Because it is in the below the this x-axis, right? Because above this is positive sigma and below it is negative sigma, okay. So this one is positive because it is above the origin, right? And this one is negative because it is below the origin, okay. Similarly with the shear stress, I mean with the base, right? This is the perpendicular and this is the base. Now base is this and this. So let us say first we will take a positive tau xy, okay. So it is going to be here tau xy, right? This is tau xy, and this is also. Now if we take the negative, okay, so it is like this, okay. So this is the geometry of this, okay. Now we know the tan, it gives us two angles, okay, and the difference between the two angles, okay, is 180 degree, okay. So 2 theta s is 180 degrees apart. It means theta s is 90 degrees apart. What does it mean? It means we have two max or min. Right now we don't know if it is minimum, okay, max or min shear planes, okay, and what is their angle, and the angle between them is 90 degree, okay. So for example, if this is one maximum shear plane, then it is automatically going to be, this one is going to be the other shear plane, okay. So the angle between them is 90 degrees, okay. So we know the angle between them is 90 degrees, okay. Now since we found the angle, okay, we found this angle, we found this formula of the shear stress, okay, maximum in plane shear stress, okay. So now let us find the magnitude of the maximum shear stress, okay. Now we know what is the value of shear stress, tau x prime y prime. I have repeated this formula many times in this video, right, and also in my previous classes. It is negative sigma x minus sigma y by 2 sine of 2 theta plus tau xy cosine of 2 theta, right? So if we substitute the, if we write here theta s and theta s, so what is this? This is the shear stress on what? Theta s plane. And what is theta s plane? It is the maximum in plane shear stress plane, right? So this will give us the shear stress on the maximum in plane shear stress plane, right? So what is this theta s? Theta is the theta s, okay? So theta s, it is this plane, right? This plane, and we call this as max or min in plane shear stress plane, okay? Now I am right now talking simultaneously about maximum and min, but I know there is only one thing, and it is maximum in plane shear stress, and there is no, I mean technically there is no minimum shear stress, okay, because I know it already, okay, but I don't want to, you know, say that right now because you didn't see why there is no minimum, right? You didn't, you know. So I will, you know, as we move on in this lecture, we will follow up that why there is no minimum, okay? But right now let us keep it like this, okay? So if we substitute this, you know, sine 2 theta s and cosine of 2 theta s from this, okay, we will get the maximum shear stress, okay? Since we substitute this tau s, so we will get tau max or min, okay? And again there is no minimum basically, okay, but as I told you, we will see, okay? So from here, let us take any of the triangle, okay? So let us find the sine 2 theta s. It is equal, what is sine? Sine is perpendicular divided by hypotenuse, okay? So the perpendicular is this, it is sigma x minus sigma y divided by 2 divided by hypotenuse. What is hypotenuse? Hypotenuse is square root of perpendicular square plus base square, okay? So it is this, you know, hypotenuse. What is it? It is perpendicular square plus base square, right? Square root, okay? So similarly cos 2 theta s, what is the value of let us substitute this value first, okay? So it is negative sigma s minus sigma y by 2. Now sine 2 theta, I will substitute this thing here, sigma x minus sigma y divided by 2 square root of under root of square root of sigma x minus sigma y by 2 whole square plus tau xy whole square plus tau xy, right? Now cosine is what? Cosine is base divided by hypotenuse, okay? So the base is tau xy divided by hypotenuse is this, right? Square root of sigma x, this square plus this square, so this, right? So it is square root of sigma x minus sigma y by 2 whole square plus tau xy whole square, okay? So let us see if we can simplify. Now this term and this term is the same, so it is going to be sigma x minus sigma y divided by 2 whole square, right? But negative is outside, right? Plus this tau xy and tau xy, it is tau xy whole square whole divided by square root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square, okay? Now there is some slight mistake, I think, because it should be, you know, they should be both the same, okay? So let me see where is the mistake. The mistake is here, just a small mistake, okay? So here when I, you know, found the value of, you know, cosine of 2 theta, it should be negative tau xy, right? Why it should be negative? Because tau xy is to the left, okay, and this side of tau is positive, but this side is negative, okay, since we are considering this triangle, okay? So it should be negative, okay? So it should be, instead of positive, it should be negative here, okay? So we have this negative, so we can put this negative outside, okay? So it is negative of this thing, okay? Now one more thing. Now we found the sine 2 theta and cosine of 2 theta from this triangle. Now what about if we found the sine 2 theta and cosine of 2 theta from this triangle now, okay? Now from this triangle, you know, this sigma x minus sigma y divided by 2, it is negative, right? Because it is in, you know, below the origin, right? So this thing is negative here, okay? So sine of 2 theta s is going to be what? Perpendicular. So right here it is going to be negative, okay. So here it is going to be negative, okay. So I will write it here. Where is it? Yes, I will write here negative, okay. Then what about the cosine of 2 theta? Cosine of 2 theta is base divided by hypotenuse. Now base is already, positive, right? So this thing is going to be positive, okay. So again, negative and negative is positive, and positive and positive is positive. So this is going to be plus, okay. So basically it is going to be plus or minus, okay, plus or minus of this thing, right? So I hope you understand. So if you don't understand, let me repeat myself again. Now from this triangle, if we found the, because we need sine 2 theta s and cosine of 2 theta s, right? Now from this triangle, if we first consider this triangle, okay, not this triangle, if we consider this triangle, okay, this triangle, from here what is the value of sine of 2 theta s? It is perpendicular divided by hypotenuse. So the perpendicular here is sigma x minus sigma y by 2, okay, and it is above, right? This one is the positive. Just let me just write the positive and negative so that we don't have any confusion, okay. But by the way, it was not needed, okay, it was not necessary because the diagram, speaks, okay. So this one is negative. Now this is tau xy, but this is negative tau xy, and this is positive tau xy, okay. Now we won't have any confusion, okay. Now sine 2 theta from this is perpendicular, so this is positive divided by hypotenuse, okay. So this sine theta is first positive, right, if we consider this. Now if we consider the cosine of 2 theta from the same triangle, it is going to be what? It is going to be base divided by hypotenuse. Now base is negative, okay. So the base is negative, right. So now let us move on to this triangle, okay. Now from here the sine is perpendicular divided by hypotenuse. The perpendicular is negative, okay. So this thing is negative now, right, negative. Now the cosine is what? Base, which is positive, right. This base is tau xy, which is positive, divided by hypotenuse, okay. Now hypotenuse is always, by the way, it is always positive because it is the square root of two things, right, and this thing is always positive. Here also this hypotenuse and this hypotenuse, they are both always positive, right. So we don't talk about these, the hypotenuse, sine of hypotenuse, okay. Now anyways, we got, when we find the cosine, we got what? We got cosine is base, so it is positive divided by hypotenuse, okay. So it is positive, okay. So in the first case, it is what? It is either it is, positive and negative, so outside is going to be negative, right. I mean this term is going to be negative, then it is negative and positive, so this term is going to be negative, okay. So when we keep this negative and negative, right, this term is negative, this term is negative, so when we keep it outside, right, so negative will be outside, okay. Then the second time negative and this thing is going to be positive, okay. So negative and negative is positive, right, so this is positive, and this negative and positive, this positive and positive is going to be positive again, okay. So positive will be outside, okay. Anyways, we have, this is our tau max or min, okay. Now we will see if we have a minimum shear stress or not, okay. So if you see this term, if you look at this carefully, okay, let me simplify this, okay. So if we call this as a, okay, this as a, and this thing is square root of a, right, because they are the same thing, okay. So this thing is square root of a, right. So we know from mathematics, a divided by square root of a is what? Square root of a, and this plus or minus is outside, right. So tau max or min is going to be plus minus, what is square root of a? Square root of a is this, square root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square, right. Now you can see this thing is the same term, okay. So let us say this sigma x, sigma y, and we know these values, okay. So when we put those values, we will get a fixed value of square root of this thing, right. So we will get plus or minus. For example, let us say we solve this, we put the value of sigma x, sigma y, tau xy, okay, and let us say we got, for example, 24, for example. Okay, now you can see these are two values, plus 24 and minus 24. And what are these? Do we have a minimum and maximum? I mean, if we look at, mathematically, if we look them as scalar quantities, okay, we see we have the maximum and the minimum. Okay, but if we look it as a, from the vector point of view, it is the magnitude of 24 and the magnitude of minus 24 is same, right? So the magnitude of plus 24 is 24 and the magnitude of minus 24 is same, 24. Okay, so they are technically, the magnitude is same. So the negative means, okay, so the negative means it is opposite to this one. Okay, so what does this, 24 but this negative? Okay, so it only means if we have a body, okay, if one is towards left or, okay, towards right, it means the other is towards left. Okay, so they are opposite. Okay, so the magnitude is same, 24 and 24. Okay, so that is what this means. Okay, so now you can say basically we don't have a minimum shear stress. Okay, so the minimum shear stress does not exist. Okay, so basically they are the same stresses, but one is in one direction. If it is in this direction, it means the other is going to be in this direction. Okay, so we don't have technically any minimum, we only have tau max. Okay, and we call this as maximum in plane shear stress. Okay, so what is the, it have a direction and it is given by tan 2 theta s is equal to, what is it, the value of tan 2 theta s is here, it is equal to, one is positive and the other is negative. Okay, negative sigma x minus sigma y by 2 divided by tau xy, right? Negative sigma x minus sigma y by 2 whole divided by tau xy, and it have a magnitude, right? So this thing tells us the plane, right? The plane where this maximum in plane shear stress exists. Okay, so we have two planes, right? Because this thing gives us two angles, right? And what is the magnitude? The magnitude of this maximum shear stress is tau max, or it is, some books also denote it with tau s. Okay, it is given by, so whole square root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square. Okay, so this is about the shear stress. Okay, and we know they are opposite to each other. Okay, and the magnitude is same. If this is in this direction, it means it is going to be in this direction. Now if in this plane one is, if it is in this direction, okay, so it automatically means the complementary stress is going to be in this direction. Okay, so the two stresses we got, they are basically the complementary, one is the complementary of the other. Okay, now let us find the relation of, this, this is the plane of the maximum in plane shear stress, right? Now by the way, why it is called in plane? Because it is always in the same plane. Okay, we rotate this in the same plane. Okay, so the plane of this, for example, if this is the stresses, normal stresses, okay, so the plane of this maximum shear stress is same as that of the, the whole body or the whole point. Okay, now let us compare this, the plane of maximum shear stress with the principal planes. Okay, now we know from my previous classes, if you remember, we know tan, 2 times of theta principal, it is equal to tau xy divided by sigma x minus sigma y divided by 2. Okay, now if we try to, write it in this way, so let me write it here. So this thing, so we can write this thing as 1 divided by tau xy divided by sigma x minus sigma y divided by 2, okay, and this negative we can keep this here, okay, so we will write this negative here. So it is one and the same thing, right? So we can rearrange this and write it, okay, but if you see this thing, it is what? It is this, right? And this thing is equal to this, right? So we can write this as tan 2 theta s is negative, right, negative 1 divided by, and this thing is tan 2 theta p, right, tan of 2 theta p, okay. So what we have tan 2 theta shear is equal to negative 1 divided by tan of 2 theta p, okay. So this is the relation between maximum in plane shear stress and the plane of principal stress, okay, or the principal stress plane, okay. So this is the relation between them, okay. Now what do they mean, okay? Now if you remember from basic trigonometry, if we have a relation like this, if tan A is equal to negative 1 over tan B, okay, it means the angle between A, okay, angle A minus angle B, okay, it is 90 degrees, okay. Now we have 2 theta s, so it means 2 theta s minus this angle is 2 theta p, it is equal to 90 degrees, okay. So it means theta s minus theta p, if we divide both sides with 2, it is going to be what? 90 divided by 2, and 90 divided by 2 is 45 degrees, okay. So what does it mean? It means the difference between the two planes, the plane of maximum in plane shear stress and the principal plane is 45 degrees, okay. So it means max shear stress or in plane shear stress, okay, is inclined by an angle of 45 degrees to principal plane, okay. So if you know, for example, let us say this is the body, okay, this is sigma x, this is sigma y, and these are tau xy, okay, and if we have this is the principal plane, okay, this is theta p for principal, okay. So this red one is the what? Principal plane. It means we are going to have what? We are going to have the maximum shear plane at an angle of 45 degrees, okay. So we don't have to separately, if in a problem we are asked to find the location of the principal plane and location of the maximum shear stress plane, we only need to find the location of the principal plane, then we will add 45 degrees and we will subtract, because the shear planes are always 2, okay. So we will add and subtract 45 degrees and it will give us what? The location of the maximum shear plane, okay. And yes, one more thing, there is also a normal stress acting on a plane of maximum shear stress, okay. So there acts a normal stress, we call it as average normal stress on the plane of maximum shear stress, okay, or maximum in plane shear stress. Now we know sigma x prime is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine of 2 theta plus tau xy sine of 2 theta, right? Now if we substitute these values, because we already found what is the value of tan of 2 theta s, it is minus sigma x minus sigma y divided by 2 divided by tau xy, right? Now what is the what is the graph of this? It is like this, right? Now let us say this is sigma x minus sigma y by 2. Let us say it is 2 theta s, okay? Then this is perpendicular and this is base, okay? So I will be talking about only one triangle here. Now we'll find the value of cos 2 theta s from here. Cosine of 2 theta s, it is what? It is base, which is tau xy, right, divided by hypotenuse, which is equal to tau xy, which is perpendicular square plus base square, sigma x minus sigma y by 2, okay, whole square plus tau xy square. Now then we have sine of 2 theta s. Sine is what? Perpendicular divided by hypotenuse. It is sigma x minus sigma y by 2 divided by square root of the same thing, right? Now if we substitute these values here, what are we going to get? Sigma x prime is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2. Now cosine of 2 theta is this, right? Tau xy divided by square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Then we have tau xy times sine 2 theta is sigma x minus sigma y divided by 2 whole under root of this, right? The same thing. Now here it was when we try to find the cosine of 2 theta, right, which is base divided by hypotenuse, and cosine here, the base, if in this triangle the base is negative, right, the base is negative in this triangle, so it is basically negative, okay, negative tau xy divided by the hypotenuse, right? Now this is here the cosine, right, so it is negative is here, so this term is going to be negative, okay. Sigma x prime is sigma x plus sigma y divided by 2, right? Now this is minus sigma x minus sigma y divided by 2 tau xy plus sigma x minus sigma y divided by 2 tau xy whole divided by square root of sigma x minus sigma y by 2 whole square plus tau xy whole square, right? Now this term and this term, they will cancel out and it is going to be 0, okay. So we are left with sigma x prime is equal to sigma x plus sigma y divided by 2, okay. Now since this is the normal stress on the shear plane, okay, we call it as sigma n, okay. This is the normal stress on the shear plane and it is the average of the sigma x plus sigma y by 2, okay. So what does it mean? If we have a body like this, if this is sigma x and this is sigma y and you found the value of theta s, okay, let us say you found the value of theta s and it is here. Now here it is going to be tau max, okay, and here is also going to be a normal stress, okay, and the magnitude of normal stress is given by this, okay. So I hope you understand everything, okay. Now if you have any doubts you can comment, okay, and that's it for today. See you in the next class. Thank you.